So this is a new unit. We're going to look at graphing and applications of calculus, of differential calculus. We're going to start with, first of all, just a review of polynomial functions and rational functions from grade 12, pre-calculus 12 math. So just we'll go over this fairly quickly, but factors and roots are related. So we have, when we do factored form, we're able to find roots. And from these roots, we can also generate a factored form. Okay, and the factors generate the roots. When we talk about these bounces and slides through the x-axis, okay, so here would be a bounce. Okay, that bounce relates to a multiplicity of 2 or power 2. And we know that the slides, the ones that go through the x-axis as slides like that, relate to a multiplicity of 3 or degree 3. So looking at these polynomial functions then, we can graph this or solve depending on the, in this case we could graph it because the y equals. So in this case we're going to graph this by factoring. The first thing we want to do is break this down by division. So we need to break it into its polynomial factor parts. So when we're going to test this out, we're going to test out possible factors, for example, plus minus 1. So we're going to try f of 1, f of negative 1. Okay, these are not equal to 0. And that's what we're looking for. We're looking for factors that are equal to 0. So I'm going to try, okay, so I'll just put plus minus 1 here. Plus minus 1, we can kind of see that that's not going to work. So we can try positive 2. Test that out, we're going to end up with 8 times 2 is 16, minus 4 is 12, plus, so it's going to be positive 12. We're going to end up with minus 26, so that's going to be negative 14, minus 6. That's going to end up being, so not equal to 0. Okay, we can test out our negatives. Okay, negative 2, and we can work that out. We're going to end up with negative 16 minus 4 is negative 20, plus 26 is going to be positive 6, minus 6 is equal to 0. So there it is. There's our one factor. Okay, so we know that that's going to be equal to x plus 2. Okay, so we're going to break this down using long division. Okay, we're actually going to use synthetic division here. So I'm going to go plus 2, 2, negative 1, negative 13, negative 6. Okay, so 2, I use the plus form, so the factor form, so I'm going to subtract. So multiply, subtract, multiply, subtract, multiply, subtract. So we're going to get our other factor here is going to be 2x squared minus 5x minus 3. Factoring that, multiply first and last, we're going to end up with 2x minus 6, 2x plus 1. Divide by 2, divide by 1. Okay, so there are many ways to factor this. Okay, I'm not going to go over the different ways to factor. You need to make sure that you understand how to factor a polynomial like this. Okay, and you need to have an effective strategy of factoring a cubic polynomial with rational roots. So there's my factored form. That generates my zeros. I'm gonna have a 0 at negative 2, negative 1/2, positive 3. We know that this graph is a positive leading coefficient, which means we should have positive slope. That means it goes through these points. Okay, we should go through negative 6 and back through here. Okay. So at this point, what I just want to highlight is we don't really know these vertices. That's what we didn't know in grade 12. But in pre-calculus 12. But now that we have calculus and derivatives, we are now going to find those out. So that's the difference between what we did in pre-calc 12 versus what we're going to do in this unit. Okay, so same thing here. We have a graph. We want to factor that and draw that graph. So I'm going to plug in. If we use plus minus 1, it doesn't look like plus minus 1 will work. Okay, so that's not equal to 0. Okay, we can try 2. We're going to have 8 plus 4 is 12. Minus, what would that be? Minus 16 minus 12, that's not equal to 0. Again, try negative 2. We end up with negative 8 plus 4. Okay, so negative 4. We're going to end up with plus 16. Okay, so that's going to be positive 12 minus 12 is 0. So there's our factor. Okay, so we're going to again have a factor of x plus 2. Okay, the 0 is at negative 2. And again, I'm going to break this down using synthetic division. So I'm going to use positive 2. What do I get here? I'm going to end up with 2, negative 2, minus, we get a remainder of 0. So I still need to break this down. Okay, so that's going to factor into x minus 3, x plus 2. So we have a double root at negative 2. Okay, we're going to have a positive root at positive 3. It's got a positive leading coefficient. Okay, it's going to bounce off of that. It's going to go through negative 12. Okay, that's our y-intercept. Okay, so again, those are pieces that we should already know. Okay, what we're going to find is, well, in this case, we do know where that bounce is there, but it's these vertices that we're going to be add on to for our calculus, so compared to what we did in pre-calc 12. Okay,